In this lesson we're going to continue to look at Hooke's law, and in particular what is meant by the elastic limit of a material. So let's just suppose our material under test is a typical metal wire, and at the moment there's no force applied to it, so we can say that the wire is at its normal length. And so what we're going to do is we're going to apply force to it, and we're going to measure how the extension in the wire changes with the force applied. Okay, so we're going to investigate Hooke's law for this typical metal wire. So we're applying a force F, and we're measuring the extension X in the wire, and we plot the points on the force extension graph, and we'll notice that the graph looks like this. So initially you get a linear region, okay, where the force is directly proportional to the extension, or the extension is directly proportional to the force, and then after a certain point the graph tends to curve off like this. Okay, so for a given force you get a much greater extension. So clearly the graph is divided into two regions. The region below this point where the graph is linear we could refer to the elastic region of the material. Okay, so that is where the material behaves elastically, and that is where it obeys Hooke's law in this linear region. What does that mean? Well, it means that while I'm in this region of the graph, if I apply a force to the wire and then release that force, then the wire will return to its original shape. We say that within this region that the wire deforms elastically. You apply a force, it stretches, you remove the force, it returns to its original shape. So we can say we've got elastic behavior in this linear region. And we're going to call this point here, this is an important point because you're often asked about this in exam questions, this is known as the elastic limit, or for example the limit of proportionality, which is quite often used in the Cambridge GCSE syllabus. Okay, so the limit of proportionality is the limit within which the force is proportional to the extension, or the extension is proportional to the force. Although you have to admit elastic limit is much easier to say. Okay, so beyond that elastic limit then the material exhibits what would be classed as plastic behavior. So if I apply a force which is greater than this force F, then the material will deform plastically. That means that when you release the force it remains permanently deformed. In other words, in the case of this wire, when you go beyond the elastic limit of the wire, then if you release that force, the length of the wire will be longer than it was at the start, which is indicated by this normal length. So what we're saying is that Hooke's law is only obeyed by a given material if you remain within the elastic limit for that material. If you go beyond that elastic limit, then Hooke's law is no longer obeyed.